Hi guys, it's a one and only maths favorite teacher once again. So on this session, we'll be basically dealing with triangle geometry, maths paper 2, grade 12. Especially if you're a student who is writing IEP, just because of you have not yet written your maths paper 2, this session basically can help you. So here we are having PA and PB. They're saying PA and PB are tangent from P to the circle ABC, right? And then they're telling you that PA is parallel to BC. So you can actually see from the diagram that we're actually having our PA being parallel to what? To BC. So it's showed by those orange lines, right? Okay. And then they're saying prove that AB is equals to AC. So for you to prove that AB is equals to AC, so it's one and the same thing with you proving that this side is equals to this side. So for you to prove that AB is equals to AC, you simply must prove that angle B1 is equals to angle C, right? So if you can prove that angle B1 is equals to angle C with respect to the angles, it means to say you will have proved that AB is equals to AC. Then now let me show you how do you prove that. So as you can see here, the hint for number one, we're going to prove that B1 is equals to angle C. How can I prove that angle B1 is equals to angle C? So I can actually see that angle A1 right there. Angle A1, it's equals to this angle right here. It's going to be equals to angle B1. Do you see? It's equals to angle B1. So reason it will be alternating. Angles are equal. Comma, it's because of PA is parallel to BC. Do you see? So that is going to be your reason. And then after that, I'm going to say angle A1, it's equals to angle C. So that will be tan-chord theorem. So remember that each and every statement should be accompanied by the reason. I'm going to use a different color to write tan-chord theorem. Let me show you. Tan-chord theorem, that will be theorem 7. So we all know that theorem 7 says that the angle between a tangent and a chord is equal to the angle in the alternate segment. So that is tan-chord theorem. So you're going to say angle A1 is equals to angle C. So you can actually see that here, based on what we are having, angle A1 is equals to B, angle A1 is equals to C. So since these two angles B1 and C, they're both equals to A1, I'm going to say therefore angle B1 is equals to angle C. So I'm going to prove them like this. Reason being is because of both of them, they're equals to A1. Do you see? So these are both angles equals to angle A1. So since both angles are equals to angle A1, that's why I told you to say the hint is that if you can prove that angle B1 it's equals to angle C, you will have proved the theorem. So now since we're having that B1 is equals to C, then I'm gonna thus conclude and say therefore what AB it's equals to what AC. And then mind you, after proving that AB is equals to AC, you must go to the diagram to show that those two angles are equal. So AB now is equals to AC. Do you get to see that? Then now we go to number 2. So since number 1 we are done, you can tick it to say now we are done. So as you are going to number 2, they're saying prove that AB it bisects PBC, angle PBC. So prove that the line AB it bisects angle PBC. So the hint again for to prove that AB it bisects PBC, you must prove that angle what? Angle B1 is equals to B2. So with regards to us proving that B1 it's equals to B2, I'm gonna prove it like this. I'm gonna say angle B2 so from what we were proving actually. So this one is proved. Let's start by writing it because we're gonna use it. B1 is equals to C. This one is proved. We proved it in number 1. So we proved it in number 1. You can consider writing it if you like. So this one is proved. So we're gonna write it here because we're gonna simply use it. And then I'm gonna say angle B2 is equals to C. Angle B2 is equals to C. So I'm gonna come and say angle B2 is equals to angle C. So the reason I'm saying B2 is equals to angle C, that is the tan-chord theorem. Tan-chord theorem. So we all know that the rule says that, which is theorem number 7, it says that the angle between the tangent and the chord is equals to the angle in the what? In the alternate segment. So that is tan-chord theorem. So don't forget, this theorem says the angle between the tangent and the chord is equal to the angle in the alternate segment. That's why I'm saying B2 is equal to angle C. That is gonna be the angle, which is B2, that is between the tangent PB and the chord AB is equal to the angle in the alternate segment represented by angle C. So we can actually see that here B1 is equal to angle C, B2 is equal to angle C. So since both angles are both equals to C, I'm gonna say therefore, what will happen? It means to say B1 it's equals to B2. And mind you, I told you that if you can prove that B1 is equals to B2, you will have proved it to say, therefore, you will have proved what? That AB, it bisects. AB does what? It bisects angle P, B, C, just like that. So that's how basically you prove this, right? So we are done with number 2. After now being done with number 2, that's when actually you can tick to say you are done with that. Then now we go to number 3. So let me now show you how we prove number 3. So number 3, they're actually saying prove that triangle PAB, it's similar. Prove that triangle what? PAB, it's similar to triangle what? Let's see. It's similar to triangle what? To triangle ABC. Similar to triangle ABC. So one thing that you need to understand, you must start with these two angles. Or those two letters, you must write them, right? So you will write P and then you must write equals to that first angle, which is angle A. So put the cap on top, put the cap on top. Then you come to right angle A is equals to angle B. Angle A, it's equals to angle B. And then you write that angle B is equals to angle C. Angle B is equals to angle C. And then after doing like this, what you are going to do now, you're going to go to triangle PAB to check what do you have. So on triangle PAB, you can actually see that I'm having A2 and B2. So it means to say here, remember that you said you are going to go to triangle PAB to check whether you're having A1 or B1 or C1. So on PAB, we're having A1 and B2. So it means to say that will be A1 and B2, just like that. And then you go again to check on triangle ABC, what do you have? You're having A2 and B1. So you're having A2 and B1. So let me just double check. A2 and B1. Yes. And mind you, don't forget that angle A1 is equals to B1. A1 is equals to B1. So that will be what? That will be alternating angles equal. So the reason why we say alternate angles is because of its alternate angles, they're equal because PA is parallel to BC. Because PA is parallel to BC. Just like that. And then let's check what's the direct relationship between B2 and C. So angle B2 and C, that is going to be tan-chord theorem, if you still remember. B2 and C, that is going to be the tan-chord theorem. The angle between a tangent and a chord is equal to the angle in the alternate segment. So this is the theorem that we'll be looking for. So I'm going to write what? I'm going to write tan-chord theorem. Remember that this angle B2 is equals to C. B2 is equals to C. That is going to be tan chord theorem. Then after writing tan-chord theorem, we are doing this because we normally know and see that each and every diagram, it should be accompanied by each and every statement, so to say, it should be accompanied by the reason. So the moment you write the statement, it should be accompanied by the reason, right? So now let's check what's going to happen with regards to angle P and A2. So P is equals to A2. So angle P is equals to A2. So there's no reason with regards to you looking at those angles. Angle P, which is this one, is equals to A2, which is going to be that one. So if there's no reason, you must always write that angle of a triangle. That angle of a triangle. Or if you don't write that angle of a triangle, you'll just write sum of angles in a triangle. Or here, you could consider writing or you'll just say sum of angles in a triangle. We know that we're gonna get what 180 degrees. So after writing that, you'll say therefore, or you'll conclude to say triangle what? Triangle PAB, it's similar to triangle ABC. Remember, you're doing maths, and each and every statement should be accompanied by the reason. So this will be what? This will be angle. So that will be your reason. Or if you don't write angle, you'll just write equiangular. You're doing maths, equiangular. So that is going to be one of our other results, right? So you can actually see that since the question required you to say prove that triangle PAB is similar to triangle ABC, you have proved that triangle PAB is similar to triangle ABC. So you can actually see that you are done, right? Proved. So now after you are done proving, it means to say you can tick to elaborate or to show that now you have mastered this, right? So this is how basically, guys, we do what? We solve these questions, guys, under Euclidean geometry. And I know that most of you grade 12, you are done doing what? You are done writing with regards to paper 2. But students who are doing IEB, these are students from private schools or that are writing the International Examination Board exams, they're still writing or they're still going to write maths paper 2. So with regards to that, I'm just elaborating this to say this video, I know that is going to impact most of you guys, and I know that you're still going to practice from here henceforth. So even if you didn't make it or the question paper was a bit challenging to you, the one that you just recently wrote for maths paper 2, you can actually make notes for yourself, and there's still a chance for you to write next year, right? Remember, time and chance happens to them all. So even if maybe you never understood Euclidean geometry when the teacher was teaching, I believe this lesson will basically help you to master all the laws of geometry that one needs to understand. So that's how basically, guys, we solve this question. And it's your one and only maths favorite teacher once again. Stay tuned for more.